Hello and welcome to today's ESA webinar. How well do you know fluid power? We appreciate everybody being here today for our Kahoot trivia game. And we do have a few housekeeping items before we formally get started. This webinar is being recorded for future educational purposes and will be made available on the ESA website within the next week or two. You will also be receiving a survey that we would love to get your feedback on within the next day or so. So please provide us some input on any other topics or events you would like to hear in the future. Without further ado, we would like to introduce to you our presenter today, Dan Turner from Turner Hydraulics and GPM Controls. For more than 4 decades, Dan has immersed himself in fluid power and remains deeply engaged with multiple fluid power businesses. He boasts numerous certifications from the Internal Fluid Power Society, such as accredited instructor title, and holds membership in the National Fluid Power Association. Additionally, he serves on the board of Equipment Service Association. Thank you, Dan, for being here. Let's get into the Kahoot. I'm going to share the Kahoot and turn the floor over to you, Dan.
Hey, thanks, Trish. Okay, so I came up with a series of questions that are fairly general. Some of them get a little bit technical into some terms for fluid power.
Dan, can you see that screen?
Yes, we can see it.
Perfect.
I can.
Awesome. Well,
so it looks. Yeah, I somehow got bumped out, so I'm no longer. Oh, I guess I can get back in. So
yeah, it has to be up on your phone. Yep. As long as you keep your phone screen on, then you'll be in the Kahoot. So when we get started, you're going to see the questions on the screen, and you're going to put your answers in on your phone. So let's try it out. And are you ready to start?
Okay.
All right.
Ready to go.
Awesome. Thanks, Dan.
Some of them are fun questions or fun answers. So, it's not all serious stuff.
You have 30 seconds to answer each question. Dan, you can feel free to read the question or they can read it themselves, but we've got about 15 seconds left.
So yeah, all of these spellings and probably 2 or 3 more are the spellings that we see for this word, and kind of never ceases to amaze me at how we still find new spellings on occasion. All right, so hydraulics is spelled with an AU and not a W. If it is spelled with an O, that is water power, by the way, but I didn't put that one on there because it would actually be 2 answers. It would be hydraulics and hydraulics with an O. So anyway, next question. Fluid power is either oil or water, oil or gas, oil or air, oil or liquid. There are 2 basic entities that go in the fluid power column. So the answer is that it is oil or gas. Water is a liquid, oil is a liquid, fluid, and liquids are fluid, and a gas is a fluid. So there was a little bit tricky, but understand fluid power includes hydraulics and pneumatics. Hydraulic pressure in the United States is in GPM, takes into consideration that we are north of the equator, is multiplied by 14.5 14.7 due to atmospheric pressure or is measured in PSI? Ah, look at that. Everybody's got it. So that is correct. GPM is a measure of flow. PSI is pounds per square inch. The amount of pressure that is against 1 square inch of surface area. And it is not 14.7, which could be in a later question. Next. Look at Jerry going to the top. Hydraulic force is PSI times surface area, HP, which is horsepower, times GPM divided by 1714, PSI times GPM, or developed after drinking a full beer stein. PSI times surface area would be the answer to that. That is pounds per square inch multiplied by the square inches that pressure is acting on. That gives us our force. Force is equal to PSI times area. Next. Pascal's law, which is a big deal for fluid power, says that crap flows downhill, pressure is inverse to horsepower, pressure is 90 degrees to all surfaces of a container, or both B and C. Okay, it is pressure is 90 degrees to all surfaces of a container. If that container has a static condition and does not have any dynamic flow that's in it, it will pressure will be equal and in 90 degrees to all surfaces. I don't know if Pascal was a plumber or not, so I don't know if he invented the crap flows downhill or whether that was somebody else. Next. Oh, look at that. The lead has changed. I guess I got to play a little bit if I even want to get on the board, huh? Okay, a safety question here. An oil injection injury may not seem bad at first, may be cause for amputation, should be treated by an injection specialist, or A, B, and C.
Dan, you should pick your favorite color since you know all the answers.
Boy, I wish I had purple on there. Actually, green. Ah, too late. I already missed it. So the answer would be all of those. So oil injection injuries should be taken very seriously. It may just look like a pinhole prick, but most likely you'll also see some swelling in that area of the oil that went in. You can get an injury like this from grease, paint, like never rub your finger against a paint sprayer to see if it's clogged or not. Any type you put your skin up against a pressure nozzle of more than like 100 PSI, you are risking injecting something into your body. Even high pressure compressed air, pressure washers, all those types of things. But whenever you get oil or some type of petroleum-based product injected under your skin, it begins to eat your flesh, and you need to have that sometimes amputated, but most of the time they'll at least like fillet you open and let the oil get out of your body instead of working its way up through the up through your finger, hand, and arm. And in one class, as I was teaching about that, had a guy raise his hand, and he was missing a finger on that hand, and he had lost it due to an injection injury. So they are to be taken seriously, and you've got to go to a specialist who understands that. Next question. Pumps. Pumps either create flow, or they create pressure, or they build pressure as the flow increases, or they produce half the pressure at half the RPM. Well, what do you pump to do? Pumps create flow. Pressure is built whenever flow encounters a restriction and starts to build some back pressure. A pump is always going to be rated at a certain gallon per minute or a liter per minute rating, and then it will have an upper pressure rating as well. So it's going to produce that flow. It's up to your system that is going to create the pressure on that pump, and then the pump is rated to be able to withstand that pressure rating. So that was good. Next question. A fixed displacement pump always has one shaft, can be a gear, vane, or a piston. Are all gear and vane pumps use a flow divider to fix the output volume? That is for a fixed displacement pump. Interestingly enough, the picture here is showing a variable displacement pump there, or a non-fixed displacement, but the answer would be they can be gear, vane, or piston. So even though piston pumps are often variable volume and vane pumps can also be variable volume, they also come in a fixed displacement type. So that is correct, except for the two people that said all gear and vane pumps, because vane pumps can have a variable volume vane pump with a pressure compensator on it. And the way they work is the ring actually gets pushed to be centered over the rotor, so there's equal volume on both sides of the gap between the rotor and the ring. A common manufacturer for variable volume vane pumps is Continental. Next. Regeneration of a cylinder, often referred to as regen, is based on Pascal's law, is based on the recycled metal percentage in that cylinder. It only retracts the cylinder, or regen extends the cylinder north of the equator and retracts south of the equator. Okay, so the answer is going to be is based on Pascal's law, because of the pressure being equal against all surfaces in a closed container. Whenever you're doing regen in a cylinder, you're basically opening up the back end of the cylinder to the rod end of the cylinder, putting equal pressure on both sides, which then creates a differential force based on the surface area of the piston, the back of the piston to the front of the piston, which is like a donut shape, because the rod cannot help hold the piston in place. The cylinder will extend if you connect the extension and retraction ports together, because the pressure is going to basically be equal within all ports, but the force is not equal because the surface area is not the same, because the rod takes up some surface area on the rod end of the piston. So regen's a pretty cool thing, and many systems will use that to conserve energy. Next. A flow control and metering valve are both adjustable, both have an orifice, are the same, just spelled differently, create a consistent back pressure. So realistically, the difference between what we call a flow control and a metering valve is that a flow control will have a bypass check. So it only meters in one direction. So they aren't the same device. They aren't always adjustable. There are many that have adjustability to them, but you can get a flow control or a metering valve that are just set by the factory. And the answer would be that they do both have an orifice, and that orifice is what meters the flow going on a metering valve both directions, or on a flow control in only one direction. Next. Cylinder pressure intensification causes aeration, is based on the cylinder ratio, needs controlled by a thermal relief, is solved by a meter outflow control. So the answer is going to be is based on the cylinder ratio. The cylinder ratio is going to be the surface area of the blind end of the piston versus the ratio, the size of the rod. So a lot of times we have a 2-to-1 ratio where the blind end of the cylinder has an area twice the size of the rod. If you go to a 3-to-1 ratio, you have a bigger rod. So the annulus area will be on a 3-to-1. The annular area, which is the area of the piston outside of the rod on the rod end, that would be 1/3 of the blind end of the piston area. So that would be a 3-to-1. So you can get intensification by putting pressure in the back of a cylinder and restricting the flow coming out the rod end. And on a 2-to-1, you can get double the pressure in the front that you're putting in the back. On a 3-to-1 cylinder, if you put in 2,000 PSI in a blind end, you could get 6,000 PSI on the rod end. So that is intensification based on the cylinder ratio. Next. So this one's kind of similar to the other question. The higher a cylinder's ratio, the higher the extension force, the stronger the rod is, the faster it will regen, the lower the PSI per GPM ratio is. Okay, we just kind of answered that one on the last one. Whenever I said like a 3-to-1 ratio, we'll have a larger rod. So you're going to have the higher the ratio means that the rod is getting stronger. A 3-to-1 ratio would be a larger rod than a 2-to-1 ratio. That ratio being basically the blind end of the piston area to the annular area around the rod. It does not give you a higher extension force. It would actually, if the ratio goes up, the regen will actually be slower because there's less oil around that rod to go back into the blind end. And the lower the PSI per gallon per minute ratio is, that's basically a made up term. So there you go. Stronger the rod is. Next. Wow, I think Vanna had all the answers. A flow control allows free flow one way, bidirectional metering, pressure to be held steady, or pressure to flow from low pressure to high pressure. So yes, I basically just answered that back on the question about difference between metering valves and flow controls. So a flow control will allow free flow in one direction. It is a metering valve with a bypass check valve. The bidirectional metering would be a metering valve that's going to meter in both directions. And the other two answers had pressure in them, and a flow control is a flow device, not a pressure device. So even though it can affect pressure, it's not going to hold it steady, and pressure never flows from low pressure to high pressure. It's always going from a high pressure to a low pressure. Next. Accumulators always get charged to 50% of the system pressure with an inert gas through the uppermost port, or both A and B. And as everybody knows, the place to get your accumulators is GPM Controls. So the answer is going to be with an inert gas. The reason it is not A and B is that there are times where you will put more pressure in the more pre-charge pressure in an accumulator if you are looking to take a surge out of the working port or something like that. A lot of times, if you're looking to use oil as an emergency, or accumulators as an emergency backup supply of fluid, then you might charge them to 50% of the system pressure, but that is not always true across every application on accumulators. You need to use an inert gas, never use compressed air or any other gas that has any combustibility or that will support combustion. You've got to use an inert gas. There are cases where people have used a compressed gas, and whatever that gas then is compressed, and there's some oil gas in there, as well as an atmosphere that will support combustion. They can diesel and they can explode. So an inert gas will prevent that and make working with accumulators much safer. Okay, next. Hydraulics can be depended on to safely counteract gravity, release all pressure when the motor or engine is turned off, cause injury or death if not treated safely, or stall before causing injury. Correct. As a matter of fact, thinking that hydraulics will safely counteract gravity can lead to death. So you've got to respect the hydraulics. You should never trust the hydraulics to be holding a load. Hydraulics do fail. You should always mechanically support that load. Like for instance, when you're using a jack under a vehicle, that is a hydraulic jack. You're going to use jack stands, so you're mechanically supporting that load before you actually crawl underneath the vehicle. I unfortunately years ago checked out a small dump truck where a guy raised the bed up. He was wiring up his exhaust muffler because he found it was easier to just lean over the frame of the truck while he was doing that. Unfortunately, the bed of the truck drifted down on him, killed him, and I went there to be able to give a report on what would have happened. And whenever I did raise the truck up and put the safety leg in, like he should have done, there was his chewing gum still with teeth marks on the muffler. And it's pretty sad to think that this guy just had no clue of how unsafe what he was doing. So you've got to think. I often say, think 3 seconds ahead whenever you're thinking or whenever you're working with things, because we don't have a 3-second rewind button. But if we can just think 3 seconds ahead, we would think, hey, I'm not going to bend in here. I'm going to walk around to the other side and put that safety leg down. Always support a bed or any load that is raised hydraulically. Do not trust the hydraulics. Next. Well, look at Brandon go. Counterbalance valve can also be used as a pump unloading valve, an over center valve, both A and B, or neither A or B. This is a pretty tricky question. The answer is going to be a pump unloading valve. A counterbalance valve is a load holding valve, but it also is called a variety of terms based on where it is in a circuit. So it can be a counterbalance valve, generally whenever it's on the blind end of a cylinder holding a load up. If that load is going to go over center, like on bucket trucks, sometimes on an aerial man lift, whenever the boom goes over center, to keep that cylinder from running away, we use a counterbalance valve, and we often term that as an over center valve. We will also use them on motors and call those brake valves. And then since it's pilot operated, we can use a counterbalance valve to unload a pump, especially in a high-low pump circuit, so that the high flow pump gets unloaded with zero pressure against it, because it's being piloted from the high pressure side, which would have the low volume pump. So yeah, counterbalance valve is a load holding valve. The other valve that is in the category of load holding would be a pilot operated check. I don't think there's a question in here that I've already, that keeps me from saying that, but a PO check valve is more of a digital device, either open or closed, and a counterbalance valve is more of an analog valve, which allows feathering to keep the load from running away. So the correct answer is pump unloading valve. Well, I'm sorry, the correct answer is both A and B. Well, I'm saying, wait, what's wrong? Should be A and B. Sorry about that, folks. Because I'm not sure if I messed that up. So yeah, I don't know that we can correct that, but I really wasn't watching the answers here, but the answer would be the number 4 there, where 4 people got it right. It is both pump unloading and over center. So we'll have to, if it's that close of a score at the end here, we'll have to look at that question. Sorry. I don't know if I messed that up or not. I probably did. Replacing a gear pump with a variable volume pump is a great idea, is too expensive, requires a pressure filter, or requires back pressure for proper operation. Okay, so of interest, I realize that I didn't frame the question quite right, and this is the first time I've done this, and so the question should be replacing a gear pump with a variable volume piston pump. If you use a variable volume piston pump, you need to have a certain amount of back pressure, and it might be like 300 or 250 to 300 psi minimum pressure. And what that does is it helps lubricate the shoes on the end of the pistons. The pistons have a a hole drilled down through them, as do the shoes, and that allows the higher pressure oil to get down there and lubricate in between the shoes and the swash plate. So you can't just use a variable volume piston pump and let it go back to tank like you would with a gear pump. However, it can be a great idea, but you also would need to change the valve probably. I mean, you would, because a gear pump is normally an open center valve going back to tank. You would need to, you would want to generally put in a closed center valve so that you're not flowing right back to tank. So you do get that back pressure. And they don't necessarily require a pressure filter, but I do say pressure filters are good on any type of system, whether it's a gear pump, which actually pushes some particles into the system. And it's good to keep any contaminants coming out of the pump from going downstream into valves. But back pressure is what you need on a variable volume piston pump. Next. Jerry's back up there. Vanna doesn't count. Oil mostly gets hot because it takes the path of most resistance because of the heat of compression, or because it goes back to the tank without doing work, or because pump compensators are set below the main relief valve setting. Oil will take the path of least resistance, not most resistance. So that was kind of a trick question, or trick answer, put it that way. Heat of compression has nothing to do with what's really going on. But when oil is built to a pressure, there is a certain amount of energy that is put into that fluid. And if that fluid does work, that's how it dissipates that energy. But if the oil goes back to tank without doing any work, it has to dissipate the amount of energy that was put into it to take it to that certain pressure. And the energy it gives off then by going from high pressure to low pressure without doing work is in the form of heat energy. And on the last one, on the green answer there, where it says pump compensators are set, if the answer were set above the main relief setting, that would be a huge heat generator. So when changing a piston pump out, always make sure that the relief valve is set just, like maybe close to 10% higher than what the pump compensator is set at. So correct deal is goes back to tank without doing work. Somebody got that one. Looks like the order stayed about the same. Hydraulic motors in series compared to parallel spin faster, always spin at the same RPM, spin slower, or spin faster and have more torque. Okay, again, we put a little trick stuff in here. Whenever they are in series, that means the oil is flowing through one motor into the other motor. If they're in parallel, they are going to split whatever flow it is half and half. Half of the flow goes through one, half the flow goes through the other. Therefore, they would spin slower. So they definitely spin faster. They don't always spin at the same RPM because we don't know that the cubic inch per revolution of the motors is the same of each other, but they wouldn't, and it does say spin the same RPM if you're going from series to parallel or compared to parallel. So you'd be going from parallel to series. They wouldn't be spinning at the same RPM. They would just be spinning faster, and they do not have more torque. The torque is actually lowered because the oil is going back to tank at 0 PSI. So in series, one motor basically dogs the other motor down. You don't get as much torque. So spin faster, somebody got it. Okay, next. Tony's moving up. Actuators are, and this is the last one. This is for all the jerky. Actuators are linear. They are rotational. They are used to shift valves. They are all A, B, and C. The answer would be they are all A, B, and C. Actuators are linear. We can have linear actuators, which are basically cylinders if it's in the hydraulic world, but you can have electrical linear actuators that it might be a motor and a ball screw. You can have rotational actuators, which could be a motor or a partial rotational actuator, which goes less than 360. And you can have actuators to shift valves, your solenoids, your levers, even they are spring centered sometimes. So there's a variety of ways that you can actuate valves. The answer would be A, B, and C. Looks like most people got that. So now I guess we're tallying. And third place, we got Tony, Jerry in second. And I think Vanna had, I don't know whether she had access to the answer sheet at one point, whether she was using it today or not. I would have to say not if she only got 11 out of 20. What's the, Trish, are you back on? Why would there be different score? What's the deal with where it says 11 out of 20, but the different scores?
I am not sure about that.
Yeah.
I don't know.
Kind of looks like we've got if you've got 11 out of 20 with 3 people, looks like we've got a 3.
It's how fast you answer.
There you go, Joanne. Thank you. Very good.
Okay.
The quickest
that's
to the
good news.
draw. Yep.
Who is Tony, by the way?
Tony Casasa.
Okay.
Yep.
And do we have an email for Tony or something? Because what we want to do is, we didn't advertise it, but we do want to send a thanks for playing gift and congratulations for getting a third to Tony, and obviously something to Jerry as well there in second place. I don't think Vanna's really going to get anything, but we'll make sure everyone that participated gets something. And Tony, do you want to send in the comments where we can reach you at, or do we have that?
I can connect everybody.
Okay, that would be great. I need an address, so we'll send him some jerky from No Name Cowboy Trail Treats. So are there any questions, if we can let everybody on to
You can just type their questions in the chat if there are any questions at this time before we wrap up.
Any questions on any of the questions or answers that we had? There is one that I saw that I need to rethink. And my question to myself, and I did this the other day on the airplane, probably about 6:30 in the morning. And I wonder if a flow control and a metering valve, I put that they both have an orifice, although one of the answers was also are both adjustable. And as I read that today, I thought, I'm not sure that I'm aware of any non-adjustable flow controls or metering valves. And most of us always think of them as having an adjustable knob on them. So I would have to look at that a little closer to determine if there is a type of flow control or metering valve that does not have adjustability to it. So that one I would also say I need to relook at that, as well as the one where I put the variable volume pump question on, where that should have said piston pump. But anyway, are there any questions?
I don't see any in the chat. Anybody have any questions?
Okay, and we're gonna follow this up then, right, Trish, with a some type of a eval form?
Absolutely. There is going to be an evaluation survey following the program that's going to be sent out via email from Zoom. So you will receive that within the next 48 hours. Dan, thank you so much for being our guinea pig on this Kahoot and doing such a great job at it. We also thank everybody who has participated today. If you do have any future questions that you think of, or something that you're curious about after the presentation, feel free to contact our presenter, Dan Turner, on the email on the screen. And
Yeah,
that
I'm available for helping out with whatever, so just let me know.
absolutely. So thank you so much. And this concludes the program. We thank you all for being here. Have a great afternoon.
Thanks, everyone. See you, Trish.